Welcome all to today's lecture. The lecture series that I am covering is for the subject VLSI Technology. Subject code is KC053. Today I'll be discussing the topic package types of VLSI devices. In this lecture, we will study that what type of packaging is used for different types of ICs, what are the benefits of using different packaging styles. Let's see what is meant by packaging and what are the benefits, what are the consequences of different types of packaging. Packaging refers to a suitable operating environment for electrical circuits. So we know that a chip is a combination of various pins, various interconnections, and we need to provide a suitable environment for every integrated circuit, that is every IC. So packaging basically refers to the environment that we are providing to an integrated circuit. The packaging of VLSI die affects the overall cost, performance and reliability of packaged die. How? The packaging should be, for example, the packaging of any integrated circuit should be so reliable so that the heat dissipation caused in the integrated circuit in the IC should have a proper sinking capability. So if we are not providing a proper package to an integrated circuit and it is getting heated up so fast, it means that the packaging is not good enough. So so we can say that packaging of VLSI circuits affects the overall cost, performance and reliability of packaged die. Now, number of input-output terminals on a particular IC is an important factor to consider. The number of input-output terminals required for logic gates and microprocessor devices. We know that the microprocessor devices carry out numerous operations, carry out a multiple type of operations needed for a particular application. So the more complex is the operation of a particular microprocessor or microcontroller or any processor, the more will be the input-output terminals on the IC of that particular microprocessor. So the number of input-output terminals required for logic gates and microprocessor devices increases continuously with number of gates on the chip. So more complex the function is, the more the number of gates are on the chip. And the number of input-output terminals, that is the input-output pins, is directly proportional to the power beta of gate count. So this is the relation between the gate count and the number of input-output pins. That is the we can say that is a logarithmic relation where alpha and beta are the coefficients to consider. Therefore, with increased number of gates, input-output count, number of interconnections and package pins are increasing at a very high rate. So therefore, since the number of input-output pins is increasing at a very high pace, so a proper packaging needs to be done for each and every IC, each and every die. So what are the needs of a good packaging, we can say? So these three parameters are very important while doing the packaging or while selecting a particular package for our IC. First of all, this is the good heat dissipation. As I already told that when we select any packaging, whatever heat is dissipated from the circuits, it spreads out in the environment of IC. And after the IC, around the IC, it gets dissipated into the environment. So every IC should have a good sinking capability so that it does not get heated up so easily and it does not get damaged or break down. Good electrical performance. Every IC should have such a packaging that it provides a good electrical performance. It should not face any problems in the connections, electrical connections during performance. High reliability. The packaging packaging of each IC should be in such a way that it does not need replacement frequently. So it should be highly reliable. It does not get damaged so easily. or it does not get wear and tear out frequently. So it should have high reliability. So these three are the critical parameters to consider while selecting the package type, that is a good heat dissipation, good electrical performance, and high reliability. Considering these three critical parameters, we can divide our package types into two types, that is through hole mount packages and surface mount packages. So these two kinds are divided on the basis of how the ICs are mounted on the circuit board. So the way the particular ICs are placed on the circuit board, that based on that we can categorize the package types into two types, that is through hole mount package and surface mount package. We will look into these packages one by one. So when we talk about the through hole mount package types, we can see that these are designed in a way that the lead pins are stuck through one side of the board and smoldered on the other side. So as we can see that these are fixed into the package. These are fixed into the plastic packaging, and the one side and on the other side the pins are free to get inserted inside the board. So that's why it is said that lead pins are stuck through one side of the board, smoldered on the other side. So these are smoldered on this side into the package. The through hole mount includes the dual line and pin grid array with pins ranging from 8 to 300. So these are the two the most popular types in the category of through hole mount package types. That is a dual inline package, DIP package. That is the most common we use in the labs. This is the form. And another one is the pin grid array, like this. So as we can see, most of the microcontroller and the advanced processor ICs looks like this. Here the pins can range from 8 to 300. So basically in this type of packaging, not many pins can be accommodated on a single chip. Using the dual inline package, we can easily, this is the most common type of package used in the today's laboratory experiments. So both types of packages are available in ceramic and plastic types. So broadly speaking, through hole mount package ICs, these are of three types, that is a single side. On the single side, basically the leads, these are the leads. Leads are fixed, that is smoldered on the one side into the package, into the plastic packaging, and they are free to get inserted into the board on the other side. So this is the single side, that is a single inline package and zigzag inline package. So here the leads are straight. So that's why it's known as a single inline package. And in the zigzag inline package, the leads are zigzag in this form. So here the leads, since the leads are zigzag in shape, that's why it's known as a zigzag inline package. So under the category of single side packaging, these two are very popular. Another category is dual side. In the dual side, DIP, that is the dual inline package, is the most popular. Here the leads can be found on both the sides of the IC. As we can see, this is the front side, and on the back side, again, the same structure is there. So on both the sides of the ICs, pins, the leads can be found out. And generally it looks like this. Here's a notch. Starting from here, suppose this is a 16-pin IC. So 1, 2, 3, 4, 5, 6, 7, 8 pins are here. 9, 10, 11, 12, 13, 14, 15 and 16. So since this is a 16-pin IC, it looks like this. Like there are 8 pins on the one side and 8 pins on the other side, starting from this pin. starting from the left of the notch. In the full surface type through-hole mount packaging, pins can be found on the whole surface. These are spread out on the whole surface of the IC. This is known as the plastic pin grid array. And these are the most common packaging types found in the advanced microprocessors and microcontrollers. So this was all about the through-hole mount packaging. The name suggests that there is the smoldering on the one side, and there is the provision of inserting the pins on the other. Surface mount package types. In the surface mount package types, this packaging follows the technology of mounting or placing the components directly on the printed circuit board surface. In this type of packaging, there is no provision of inserting the pins inside the board. Here, the components are directly mounted onto the printed circuit board. Like as we can see in these figures, pins are so small that they cannot be inserted in the board. They are directly mounted onto the board. Although this process of fabrication helps do the things quickly, it also increases the chance of defects. Because why there are the chances of defects in this type of packaging? Because we can see that in this type of packaging, the spaces between the pins is very less, and also the pins are very small and thin. So since due to the extreme closeness between the pins, the defects are very prominent to be found in this type of packaging. All surface mount packages are available in ceramic and plastic packages. So here also, all these surface mount packages can be found in ceramic or plastic packaging. Again, when we divide the surface mount packages, we can broadly divide them as single, dual and quadruple. As the case similar to through-hole mount, in the through-hole mount there were three types: single, dual and full surface. In surface mount packaging, there are again three types: single, dual and quadruple side. In the single side packaging, the name of the packaging style is SVP, that is a surface vertical mount package. As we can see that the pins are vertically mounted onto the printed circuit board, and this is the this shows that how the IC is attached onto the board. When we talk about the dual side, there are three types of packaging. First is this SOP, that's a small outline package. Another is thin small outline package. Another is small outline J lead package. Let's see what are these. In the small outline package, we can see these leads are very small. They are extremely small in size. And your IC is thick enough, you can see. But in the thin small outline package, your IC, that is the packaging, is very thin and leads are very small. That's why it is known as a thin small outline package. Now, small outline J lead package, in this type of packaging, we can see that pins are J shaped, like this. So this is the small outline J lead package. Now when we talk about the quadruple side, here we can see quad flat package. Why named quadruple? Because pins can be found on all the four sides. And the package is flat square shape. Thickness is quite noticeable. Again, in this thin quad flat package, thickness is not noticeable, very thin, and pins can be found on all the four sides. Again, quad flat J lead package. This is similar to the quad flat package, but with the pins shaped J, like this. So these are the different types of surface mount packages. So we can see in the packaging types, there are broadly two types of packaging, that is a through hole mount packaging and surface mount packaging. In the through hole mount packaging, we can see that the pins are attached, smoldered on the one side and free to get inserted into the board to get attached to the board on the other side. In the surface mount packaging, we can see that the chips or the ICs are mounted directly onto the printed circuit, that is a circuit board. So these are the differences between the two types of packaging. Though the packaging have their own advantages and disadvantages, and depending upon the complicated circuits, depending upon the applications, we can select any of the packaging styles. Now the next subtopic within this packaging is the packaging design considerations. Whenever we select the packaging styles, we have to take care of these four considerations, that is the design considerations. First is the VLSI design rules, another one is the thermal design considerations, electrical considerations, and mechanical design considerations. When talking about the VLSI design rules, in order to achieve high yields in VLSI package assembly, establishment of good design rules is very necessary. So the design rules have to be followed so that we can come up with the good yields. That is the ratio of the good ICs is high enough. And also this is noteworthy that rules must be different for the particular package types. The rules must be compatible with the assembly equipments. So these are the important points to consider. As the input-output gate count grows, that is the active and VLSI device size shrinks. The bonding pad size and the spacing should be reduced. So what it wants to say is that as the input-output count is growing and the VLSI size is shrinking, the bonding pad size and the spacing should be reduced. What is meant by this bonding pad? On the particular IC, these are the pins. So the distance between these pins is reducing day by day, owing to the increase in the input-output count and owing to the shrinking in the device size. When talking about the thermal design considerations, the operating junction temperature of a silicon die must be as low as possible to prevent the failure rates. So what we want to say over here is that the IC should not get heated up easily. The heat is transferred from the die to the surface of the package by conduction and from the package to the ambient by convection and radiation. So such types of packaging materials should be used so that the heat can be dissipated properly. Considering the electrical considerations, here there should be low ground resistance, that is a minimum power supply voltage drop should be there. Signal leads should be short enough so that they offer minimum self-conductance. Another important point to note is the minimum power supply spiking due to the signal lines simultaneously switching. As we know that due to the high level of integration, there are the millions of interconnections present on a single IC. And due to the simultaneous change in the signals within these interconnections can leads to the spiking, which has to be avoided. Maximum use of the matched impedance should be encouraged to avoid signal reflection. Another, the proper noise reduction techniques should be applied. What is meant by the noise? Let's understand that when a line switches, the voltage induced in the ground line is given as Vi is equal to Lg di by dt, where Vi is the induced voltage and Lg is what? Lg is inductance of the ground lead. Di by dt is the derivative of the current with respect to time. So here if the J lines are switching, then what is happening? This equation looks like this. This very particular equation is for the single line. Now if there are multiple lines, how it looks like this. So there is a summation of change in the current with respect to time for J lines. So in order to reduce VI, the multiple ground leads should be used to reduce LG. The inductance can be reduced through the use of large ground planes within the package. So for better electrical properties, the large number of ground planes should be used in a single package. When talking about the mechanical design considerations, the material for package construction ideally match physical properties of the VLSI die. That is the thermal coefficient expansion. This very particular property should be matched. This is because the die is attached using the materials like solder, alloy or adhesive, and during the packaging process the heat may melt the solders. So we have to make use of such substances, such components, so that the thermal coefficient expansion is matchable. So alloy 42, that is the combination of iron and nickel, where the nickel is 42%. This is the perfect alloy combination which is used, and it has the poor thermal conductivity but closely matches the thermal coefficient of expansion for silicon. That's all for today. Thank you.